All right, now we're going to take a look at a few more examples for balancing equations. Remember, balancing equations, the other word you might hear for about it in high school is going to be stoichiometry, which is a crazy word. Essentially, it's kind of like a recipe for chemistry. So when I was in middle school, we got to take home ec, and I remember that one of the first things we made in home ec class was Rice Krispie treats. So the recipe for Rice Krispie treats is you need 40 marshmallows, 4 tablespoons of butter, and 6 cups of cereal, and that will make enough Rice Krispies for a 9 by 13 pan. But what if I wanted to make a smaller batch, like an 8 by 8? What if I wanted to make a big party size, like a 20 by 20? This sort of math idea is exactly what scientists are thinking about when they're studying stoichiometry. How can they change their yield of a particular chemical equation? There are 5 steps that your textbooks will reference in how to solve a balancing equations problem. First, and this is something that we'll usually do for you, is write out the equation using the symbols and the subscripts. Second, which is usually where we start, is you need to count how many of each type of atom you have on the left-hand side of the equation and how many you have on the right-hand side of the equation. Then here we are at step number 3. You want to make sure that we are adding coefficients to balance the reaction. So you can't change the subscripts. The subscripts are there to represent how the atom is bonded together. So the only thing you can do is add a coefficient to describe how to balance the equation. You also need to make sure that your coefficient is a whole number. You can't have any fractions or decimal points. Then you are going to distribute to make your coefficients. And you want to double check and make sure that you have all of the same type of atom on each side of the equation. So let's go ahead and do a little bit of practice. Here we have nitrogen and hydrogen combining to form ammonia. So again, this is step 1. Everything's already written out. Step 2 is that we need to count. So I like to draw a line and figure out what kinds of elements do I have on each side of the equation. In this case, I have 2 nitrogens on the left and I have 2 hydrogens on the left. I count, I have 1 nitrogen on the right and I have 3 hydrogens on the right. So I'm going to need to add some coefficients in order to balance this equation. So you can choose to start anywhere you like. It really isn't a perfect system. It's kind of trial and error. So if I see that I have a 2 on the left and a 1 on the right, that's a pretty easy fix. So I'm going to put a coefficient of 2 in front of that NH2. Now I have 2 N's on the right-hand side of the equation. You have to remember that that affects both pieces. So now it's 2 times 3 will give me 6 hydrogens on the right-hand side of my equation. So I've fixed one thing, but I've messed up another. That's okay. It's kind of the way it goes. So I'm going to go back over here and I need to fix or balance out my hydrogens. So I'm going to put a coefficient of 3 because 3 times 2 will give me 6 hydrogens there on the left. So I've added my coefficients. Step 4, I'm going to double check, make sure that everything balances out. If I want to, I can put that coefficient of 1 in front of my N2, but that's really optional. And then lastly, we'll make sure that everything checks out, and we're good. This is a finished balanced equation. All right, things are getting a little bit more complicated. Let's take a look. We've got aluminum and sulfur making aluminum sulfide. So we're going to have aluminum and sulfur, aluminum and sulfur. We're going to count how many do we have on each side of the equation. 1 aluminum on the left, 8 sulfurs on the left, 2 aluminums on the right, and 3 sulfurs on the right. So when I look at this and I see 2 and 1, that's easy to fix. But now I'm looking at sulfur and I've got 8 on the left and 3 on the right. Those two numbers are a little bit more different than I'm used to. So I have to think about this, kind of like you do in math class. What's the smallest number that both 3 and 8 will evenly go into? 3 and 8, well 3 times 8 is 24, so I might as well try that. If I put a coefficient of 3 on the left-hand side, now I have 3 multiplied by 8, I have 24 sulfurs on the left. If I put a coefficient of 8 On the right-hand side, this is going to affect both pieces of that molecule. So 8 times 2, now I have 16 aluminums on the right. 8 times 3, now I have 24 sulfurs on the right. So again, this is kind of a system of checks and balances. My sulfurs are balanced, but my aluminums, I need to go back and put a coefficient of 16 in front of that aluminum. And now I'm going to double check, make sure everything's correct. I have 16 aluminums on the left, 16 aluminums on the right, 24 sulfurs on the left, and 24 sulfurs on the right. So 16, 3, and 8 are the coefficients for this balanced equation. This is probably one of the most challenging pieces we'll get to. It does get a lot more complicated when you get to high school, but for middle school, this is probably about as complicated as we'll get. So this is the challenge problem I'm going to leave you with this afternoon, and we'll talk about how to finish this or how to solve this tomorrow in class. See you next time.